Welcome back to the discussion of spatial computing. In this video, I would like to describe a current research project in our own group. If you saw the other video on research project, you already know, ours is spatial computing research group, and we have helped contribute books, encyclopedias, we help manage journals and conferences and so on in the area. And you also saw a recent community visioning report, which is recommended reading for module 8. And that you can see many more exciting vision or current research ideas in the community. Okay. Now, our group specializes in two sub areas of spatial computing, spatial databases, which was the focus of another video, and spatial data mining, which is the focus of this particular video. So starting roughly 99, we have started working in this area. And it all started with the NSF workshop, which brought in researchers from GIS and data mining together back in 99. And we, after end of 3 days, I left with a kind of interesting feeling. I felt that people could do a lot more in this space. Most people were using the plain old vanilla data mining for geographic data, but there was potential to do more. And a lot of that you saw in module 4 when we talked about spatial data mining. We have spatial autocorrelation, we have continuity and so on, and you can do different things. So in that particular module, you saw the location prediction problem. This was one of our first projects, and we saw that if you make IID assumption, things don't go very well. So to predict that bird nests, it's important to model autocorrelation. Another project shortly afterwards was spatial outlier detection, and you probably remember this diagram, the freeway map of Twin Cities, and the data from I-35W, which is shown here, and you remember sensor number 9 was behaving very different than its neighboring sensors. And this discontinuity was formalized as spatial outlier. You also remember the collocation discussion in module 4, and this was a generalization of association rules, but overcoming the challenges of lack of transactions. Okay. Now beyond that, we have now also recently completed a very nice work on summarization. You probably remember your k-mean and sat-scan discussion from module 4. So currently, if you think about those techniques, if you give them data sets like road accident, they would find ellipses as are shown in these two pictures. Okay. However, you may realize that if the data set is really constrained by the road network, a better summarization is by routes, by network concepts. So in our group, a thesis just got completed on KMR, which instead of finding ellipses, it finds routes which have very high concentration of activities. Okay. Now, going beyond that, let me give you two other, or three other examples of things that are going on in our group. So first, let's start with collocation. Remember, in collocation, you were given a set of, features and several instances of those features and a map of those. And we were looking for pairs of features or triple of features which were collocated. Okay. Now, this work has been extended to space and time. Okay. So now try to imagine we have a set of crime reports, and for each crime report we know the location and time. So maybe if you're looking at a particular event such as bar closing around midnight in many urban areas, we might find at time t equal to 1, couple of bars close. Okay. Now shortly afterwards you see some minor crimes happening around in the neighborhood. Okay. And shortly afterwards you see drunk driving arrest a little bit further down. So when you see data sets like that, we can essentially define a pattern called cascade and summarize it using this simple diagram. And what this is essentially indicating is that in some areas, in downtowns with very, very large, dense population, bar closing events are often followed by assaults, little time, shortly afterwards in the immediate neighborhood, or drunk driving arrest little bit further down, shortly afterwards. And this is called a cascade pattern. And this may be a better summarization than simply looking at the map. Okay. So our group, there was a thesis completed with a DoD research funding, and you can, if you are interested, you can see more details in this IEEE transactions paper. Okay. We also extended collocations to moving objects, and to illustrate that, let me show you this example. And here we have trajectories of many moving objects. The object type is being shown by the color. Okay, so there are some people moving around here, and there are some heavy vehicles moving around here, and the question is is following: do you see pairs of colors or subsets of 3 colors which are often together in space and time, even though they are moving? Okay, And as you can imagine, so I will, you may want to pause the video here and look for those patterns. Okay. So I assumed you did that. So when you come back, you will probably find the pair blue and red moving together, and that's the highest interaction. You might even see yellow involved in that a little bit. Okay. Now again, for small data sets, you can do that manually, but as the number of trajectory and vehicle types increases, you need smart algorithms to sort through those and rank them. Okay. And these results are reported in another IEEE transaction paper here that you can take a look at. Okay. So let's talk about a current project. What are we doing right now? And one of the interesting project has to do with looking for hotspots of activities in presence of evasion. Okay. So this is motivated from analysis of serial crime. So if you go to environmental criminology literature, they often talk about an interesting phenomena called donut hole patterns, and where do they come from? Okay. And here is the theory. So if you imagine there is a activity generator like a serial criminal, then it has been observed that they don't commit crime in their immediate neighborhood because their neighbors know them and they can kind of report them back. Okay. But then they don't go too far either because there is transportation cost. Okay. So if you really see what their crime pattern footprint will look like, it will look like a donut hole, sort of like this. You see these red dots are the activities, and it will kind of be scattered in a ring-like manner. Okay. Now this has been observed for a long time in police work, and people have actually mapping and manual techniques called geographic profiling. So once they have connected these crimes by their MO, and they want to know where the serial criminal may be living, they essentially go inside this hole and they try to do screening in there. Okay. But the big question is, could we design algorithms, fast algorithms to find these patterns? And with one current grant, we are exactly exploring that problem. Okay. So first, we simplified the problem a little bit to make it computationally tractable. So we assumed that these donut holes are concentric rings, okay, just to reduce computational cost. So in terms of the problem input and output, you are given a set of activities and their location. For example here, so these red dots in this map is essentially showing you arson. Again, there are people who start fire by their weaknesses, and many of them become serial. So this is an example from Southern California. Okay, so a lot of arsons started by same person, same MO. Okay, in addition, these things we want to be very, very sure that we are not really, trying to harass people who are innocent. So that's why we want statistical significance, very much like SAT scan. Okay, and then the output is ring-shaped hotspots which are statistically significant. Okay, so in this particular case, you see some red dots down below, some over here, and the output are these rings which are shown in green. And with each ring, we have statistical parameters, the p-value and the confidence measure. Okay. So the idea is to give statistically significance rings, very, very quickly. Okay. So this work just started. We have a paper in IEEE International Conference on Data Mining in December. So really fresh, hot off the press, and this thesis will be ongoing. So again, just to acknowledge, this particular work was actually sponsored by Department of Defense, and here are some of our other current grants, which is sponsoring other activities. In fact, through other videos, you would come across what else is happening. So for example, this expedition, Understanding Climate Change, a Data-Driven Approach, I am a co-PI, and we will have a video interview of Professor Vipin Kumar, who is the PI, and you can see some data mining work there. You will also meet Len Kane, who is heading this initiative called Use Spatial, which provides spatial services to the entire campus. Okay. So again, it's a vibrant set of projects down here, and we are very, very grateful to the sponsors who sponsored this kind of projects. So thank you for your attention. You got a sense of another research project in my group, and hopefully through other videos you can see what other people are doing in the campus as well as around the country.